Hi everyone, my name is Srinath Krodekar and I'm a solutions architect on the Amazon File Services team. And welcome to this breakout session where I'll be talking about how to choose the right cost-effective AWS file system. I'm excited to be back in DC, one of my favorite cities, and talking to you in person. Just by a quick raise of hands, how many of you are familiar or using AWS file systems today? Okay, see quite a few. Exciting. All right, so what we'll do in this session is, I'll walk you through the different AWS file storage offerings that we have available, and then talk about, the different stages of cloud journey that our customers are adopting and how they are leveraging our file services today. With that, let's jump right into it. AWS offers the most complete cloud storage portfolio. One of the most important decisions you need to make is where do you store the data, right? At the core, we have object, block, and file. We have the deepest set of data services comprising of AWS Backup for data protection, AWS Transfer Family, which allows you to transfer files in and out of AWS services securely, and a rich set of capabilities like deduplication, compression, and intelligent tiering, which allows you to optimize costs. We have a broad set of data movement services. By using AWS Data Sync, you can perform online migrations or use our Snow family of services to perform offline migrations. We have a broad set of hybrid and edge storage services. You can deploy AWS Outposts in your on-premises data centers, or you can innovate anywhere you want by using the AWS Snowball Edge device, where you can bring compute and closer to your remote office locations and innovate faster. Right. In this session, we are going to focus on file storage and help you understand what is the right file system choice depending on where you are in your cloud journey. Right. We see customers using AWS file storage across a wide range of use cases. These use cases are databases, Oracle or SQL databases, high-performance computing workloads, machine learning training, corporate IT applications, software build environments, right? And why do customers use AWS file storage? Right? One is simplicity. Right? You can access data as files and directories using native OS APIs. Then next is shared access. Right? Users need to collaborate and access the same set of data. And applications need a shared storage platform where they can share the data across multiple compute instances. The next critical reason is high performance. Right? All our AWS file storage services are built and optimized for high performance, offering high levels of throughput, IOPS, and low latencies. And finally, rich set of data capabilities. Customers need rich data capabilities like snapshots, cloning, intelligent tiering, and our services offer that. And precisely for these reasons, there's over 100 exabytes of storage in the form of file storage used by applications today. So these are all the different AWS file storage services that we have available today. Right? As of last year, we launched 2 new services, Amazon F6 App on Tap and Amazon Open ZFS, making it a total of 5 services under the portfolio. Right? So depending on your requirements, we have different file storage offerings. If you are building serverless applications, then we have Amazon Elastic File System, which is a fully elastic, simple set and forget cloud-native file system. Okay. And this was one of our first file storage offerings that we launched at AWS. For your on-premises file storage workloads, we have the Amazon FSx family of services, which are fully managed file systems powered by commercial and open source file systems. 90% of what we build at AWS is driven by what customers have asked us for. Customers wanted an easy migration path and they wanted to easily lift and shift their on-premises file workloads into AWS. So for that, and precisely for that reason, first we launched Amazon FSx for Windows File Server, which allows customers to migrate their on-premises Windows file storage to AWS. Customers asked us for a high-performance, compute-intensive use cases. They wanted a high-performance file system. And for that, we launched Amazon FSx for Lustre, which is a scale-out file system offering, allows you to scale to hundreds of gigabytes of throughput and millions of IOPS. It's built on open source Lustre and is a popular choice among top 100 supercomputers in the world. And last year, we added Amazon FSx for NetApp ONTAP and OpenZFS. Customers wanted an easy migration path to lift and shift their NetApp on-premises workloads. They were familiar with all the rich feature sets that NetApp has offered, and we worked in close collaboration with NetApp to build the NetApp ONTAP service and launch it for our customers. And with Amazon FSx for OpenZFS, it enables you to migrate your ZFS or NFS workloads and provides the lowest latency NFS file storage offering in the cloud. Customers have been telling us that managing on-premises NAS can be complex, costly, and difficult to scale. More and more customers are moving their file storage environments to AWS because they want to improve agility, reduce costs, and innovate faster. And as part of their migration journey, they're also modernizing their workloads using containers and serverless, and they need a persistent file storage for these modern applications. Now, let's look at the different stages of the cloud journey, right? We have customers that are at different stages of the cloud journey leveraging our file services. And we see three major trends when it comes to what our customers are doing. The first is they're operating in a hybrid model and extending their on-premises environments into the cloud. The second trend we see is customers want to accelerate their cloud journey and migrate their on-premises environments into AWS. The third trend we see is customers are building net new cloud-native applications using cloud-native services in AWS. And as you may expect, file storage is used across most of these applications and is critical at every stage of this journey. Let's dive a little bit further into how customers are extending their on-prem workloads into AWS and operating in a hybrid model. Okay. So there are primarily three different use cases how customers are extending their on-premises workloads. One is they are building their disaster recovery in AWS. They're continuing to use their on-premises environment as production site and extending their DR into AWS. Second, they are backing up their data into AWS and having a second copy of the data in AWS. And finally, they're bursting their workloads to leverage the scale and agility of compute at AWS and burst their workloads to cloud. Across all these use cases, customers wanted a file storage service that can offer them a simple and easy way to access across on-premises and cloud, right, which can be accessed from anywhere and provides the durability, availability, security, and performance that customers want for their applications. In order to set up disaster recovery in AWS, right, so this is an example that I'll walk you through how you can set up your disaster recovery in AWS. You have your on-premises infrastructure and your on-prem file storage environment. You set up a DR site in AWS, and then you can use one of our migration technologies. You can use AWS Data Sync with all our file storage offerings, like FSx for NetApp ONTAP, FSx for OpenZFS, Lustre, Windows File Server, or EFS. With FSx for NetApp ONTAP, we support native SnapMirror replication. Right? So customers can use native SnapMirror to replicate the data and keep the DR environment in sync on an incremental basis. Now let's say the on-premises data center goes down, right? You can optionally scale up your AWS compute and storage. You can start smaller, and if you were to fail over from your on-premises environment to AWS, you just scale up your storage and compute and go live with production. And continue to run your workloads there until your on-premises data center is back available. Once your on-premises data center recovers, you can replicate the data back using either AWS Data Sync or NetApp SnapMirror with FSx for NetApp ONTAP file system back to your on-premises environment. And then you can optionally scale down your AWS compute and storage, and thus allow you to build DR in AWS and optimize for costs as well. Right? In addition to setting this up, you can do other things like when you're setting up the DR, you can enable tiering policies if you're using FSx for NetApp ONTAP or intelligent tiering, right, with both EFS and FSx for NetApp ONTAP, and optimize costs for your DR environment as well. I'll talk a little bit more about that in the subsequent slides. You can also protect your data, having a second copy of the data in AWS for your NetApp infrastructure on-premises by using NetApp SnapMirror. SnapMirror performs quick, efficient incremental transfers of the data, allowing you to quickly replicate the data from your on-premises storage environment into the cloud. You can also use capabilities like NetApp SnapVault to offload your backups from your on-premises environment into the cloud and retain your backups in the cloud. The final trend that we see is cloud bursting. Right? When customers are operating in a hybrid model, customers have large data sets that are built on their on-premises storage environment. And oftentimes, their workflows require only a portion of the data set, and they don't know what portion of the data set that needs to be available. And they're limited by the amount of compute that is available for them to scale on-premises. And customers really like the capability of the scale at which they can scale their compute in AWS and burst their workloads to cloud. But in order to do that, they need the data to be closer to the compute as well. Right? Now, instead of migrating all your data and may bring it closer to your compute, if you're using if you're using a NetApp file system on premises, using FSx for NetApp ONTAP and the Flex Cache capability that we support with it, you can create a cache for your on-premises data center or on-premises data using Flex Cache and burst to the cloud. When you create a Flex Cache on your FSx file system, you link it to a volume on your NetApp file system on premises, and that will start caching the data and allowing you to burst those workloads to the cloud. The reverse is also true. Let's say you are hosting the data in AWS, but you want the data to be available at low latency access for your on-premises clients or for from remote office locations. So you can use the same Flex Cache capability, or you can use Global File Cache capability, which is available with FSx for NetApp ONTAP, and bring that data closer to your on-premises compute or clients. Or if you're using our Windows file server file system, then you can use the FSx file gateway to cache the data and bring the data closer to your on-premises clients. Okay. So next, let's look at the migrate journey, right, where customers are looking for an easy lift and shift for their existing on-prem workloads. Customers have built applications, workflows, and skill sets around specific file systems, right? And the on-premises file systems provide rich set of capabilities like snapshots, cloning, tiering, antivirus scan, etc. They're built for performance to meet their application workload profiles, and rich set of data management capabilities like backups, tiering, etc. And migrating to a different storage solution often requires re-architecting, recertifying, or retraining your staff. Right? And this is why we have two migration paths for customers. Right? You can choose to migrate like to like, where you start with the file system that you're using on premises and move to a like-to-like file system in AWS and get the same set of capabilities. Our FSx family of services are precisely built for that, right? So using FSx for Windows File Server, FSx for NetApp ONTAP, FSx for Lustre, or FSx for OpenZFS, you can migrate, similar file system types that you're using on premises without having to, re-architect, recertify, or retrain your staff into AWS. If you don't have a like-to-like file system, then the second path is workload optimized, where you start with, capabilities that you need for your workload, right? And explore the broad selection of, fully managed file systems and the capabilities that we have that best serve your needs for these file systems. Okay. The link that I have here is from our documentation page and provides a step-by-step comparison of all the rich capabilities that are available across the file storage portfolio. Right? And I'm going to dive into some of these shortly. Let's look at what that like-to-like migration looks like. Right? As I mentioned, the FSx family of services provides you a seamless migration path for your on-premises file storage-based applications. Okay? So if you're using a ZFS file server on-premises, or if you're using a DIY NFS file server, either in AWS or on-premises, we recommend you migrate it to Amazon FSx for OpenZFS, because that's the simplest migration path and provides you, the like-to-like capabilities. If you're using Lustre or any scale-out parallel file system, you can use Amazon FSx for Lustre as the choice of file system. If you're using NetApp on-premises, then we have Amazon FSx for NetApp ONTAP designed for it. If you're using Windows File Server on-premises, then we recommend you migrate to Windows File Storage in the cloud. And across all these services, for OpenZFS, Windows File Server, and Lustre, you can use AWS Data Sync to perform online migrations, or use Snow family of services for offline migrations. With FSx for NetApp ONTAP, you can easily migrate the data using SnapMirror, or use Snow family of services to perform offline migrations. Okay. Now, what if you don't have a like-to-like offering and you want to explore the capabilities that meet your workloads, right? So in that case, these are some of the key capabilities of the different file services, right? And our documentation page, the URL that I showed earlier, provides you, a very detailed comparison that will help you, make the right choice. If you're building serverless applications, right, Amazon EFS is a fully elastic, cloud-native set-and-forget file system. You provision the file system, and you don't need to worry about, managing the capacity. The file system will grow as you add more data and shrink as you delete more data from it. The throughput, or the performance, also scales with the amount of storage that you grow and shrinks, based on the amount of storage that you reduce from the file system. Right? So it's fully elastic in nature. You also have the choice of, provisioning throughput, where you can, provision a fixed amount of throughput if your application wants, consistent levels of performance with Amazon EFS. With Amazon FSx for Lustre, this is optimized for scale-out workloads and can scale to hundreds of gigabytes of throughput and millions of IOPS. Right? This is designed for those compute-intensive applications, and it's also integrated with S3, allowing you to access your objects in S3 as files and directories, providing you a POSIX interface, and allows you to process your data set faster using the scale-out capabilities of Lustre at sub-millisecond latencies and hundreds of gigabytes of throughput and millions of IOPS. If you need the rich set of data management capabilities that our FSx for NetApp ONTAP file system supports, right? Things like multi-protocol access, where you need to access the same data from both Windows as well as Linux clients using SMB or NFS protocol, or whether you need intelligent tiering, snapshots, clones, replication, or optimized cost using storage efficiency features like compression, deduplication, et cetera. or need capabilities like antivirus scanning for your applications, then Amazon FSx for NetApp ONTAP offers all those rich feature sets and would be the preferred choice of file system. If you just need a simple NFS file system that is cost optimized and is designed for high performance at low latencies and is optimized for small file workloads, and also provides data management capabilities like snapshots, clones, replication, and compression, Amazon FSx for OpenZFS provides you those options. And finally, with Amazon FSx for Windows File Server, this is built on Windows file storage and is the simplest solution for running your Microsoft workloads, including SQL Server workloads. Here's an example of a customer, eHealth NSW. They're a lead digital agency in the public health system for New South Wales, Australia. And they were using NetApp on-premises for their medical image repository. And they really wanted to reduce their operational burden because they were managing all this infrastructure on-premises and migrate it to cloud. They really liked the rich feature sets that were offered by NetApp ONTAP. Right? And they migrated over 1.3 petabyte of their NetApp on-premises medical image repository into FSx for NetApp ONTAP and reduce that operational burden while retaining all those rich capabilities like snapshots and clones, which they liked. Once they migrated this workload, they then started evaluating our other services, and they are migrating their patient administration applications to Amazon FSx for Windows for a simplified management. And for the genomics environment, where they need that scale-out performance of Lustre, they are developing genomics analysis using FSx for Lustre. Finally, let's look at the third stage of the cloud journey, where customers are building net new applications, cloud-native applications, using the AWS services. Let's dive into why customers are building net new applications, and while building that, they are modernizing their applications as well. Okay. So there are three main reasons why modernizing their applications and building cloud-native applications is beneficial for customers. One is cost. Right? So you can save cost by reducing the operations burden and underutilization of storage. Customers often need their environments to be separated for security reasons and end up deploying infrastructure, which leads to underutilization. Or oftentimes, they need to plan their storage and compute to meet the peak demands. But oftentimes, it leads to underutilization. Right? By using our container services or serverless compute and using our file storage services, they can start small. Right? For example, with EFS, it's fully elastic, and it will grow and shrink based on application needs. Or with our FSx family of services, you can start small, and you can scale up your storage or throughput to meet the application demands. So customers really like that agility where during peak demand, they can quickly scale their compute and storage to meet the peak demand. And once the peak is over, scale down their infrastructure. Okay. Customers are building their development processes around containers and serverless and using elastic services. This allows them to improve their development cycles and innovate faster. Okay. Now, customers that are building these cloud-native applications need that file storage service that is persistent and durable and provides shared access across all these containers and serverless. So if you are building serverless applications using AWS Lambda, right? Amazon EFS is tightly integrated with Lambda, and when you create your serverless applications using Lambda, you have the option to configure a shared storage using Amazon EFS. And a recommended choice of storage for your serverless applications is to use Amazon EFS. If you're building container applications using EKS or ECS, then you can use either Amazon FSx or Amazon EFS for these container workloads. The choice really comes down to, again, that capabilities that we offer and what you need for your workloads. If you need a fully elastic set and forget file system, then you can use Amazon EFS. It's a great fit. But if you need some of the capabilities that the FSx file systems provide, right, like cloning, snapshots, or native replication, or need low latency and scale-out performance, then FSx is a good fit for your container workloads. Finally, if you're using AWS Fargate, where you don't need to worry about managing the containers, then Amazon FSx is the default choice for your AWS Fargate applications, because Amazon EFS has native integration and provides you that shared storage access from your AWS Fargate application workloads. Next, let's look at how you can leverage cloud scale storage to process your data sets faster. Right? So far, we talked about the different trends in the customer journey, where customers are either extending their file system and operating in a hybrid model, right? Or migrating their applications to the cloud, or building net new applications in the cloud. Right? Once the data is in the cloud, right, customers are also building data sets outside these file storage services. They're building data lakes in S3. Right? And they want to, data is everything in today's world. And customers want to get, meaningful insights out of the data. They want to analyze the data, process the data faster, right, for different use cases, right, analytics, machine learning, et cetera. Right? And the native integration that we have with FSx for Lustre enables you to do that. Right? You can link one or more Amazon S3 buckets or prefix to your Amazon FSx for Lustre file system. And when you do that, all your objects from your S3 bucket are going to be transparently imported as files and directories into the Amazon FSx for Lustre file system. So you can view all the S3 objects as files and directories from your FSx file system, and provides you that POSIX interface where you can mount it on your compute, just like a POSIX file system. Right? Once the data is in the FSx file system, now the scale-out capabilities of FSx for Lustre allows you to process your data sets for your analytics, genomics, or machine learning training workloads at sub-millisecond latencies. Right? And you can the scale-out performance, where you can scale to hundreds of gigabytes of throughput and millions of IOPS, enables you to process that data set faster. Right? The integration with S3 allows you to also automatically import the data. Right? You can configure auto import, where anytime you upload a new object in your S3 bucket, will be transparently visible in your FSx file system. Okay. You can also enable auto export, where anytime you modify or change a file on the FSx file system, it will be automatically copied to your S3 bucket. So that's like a two-way cache for you. Okay. So here's an example of an EDA customer and how they are leveraging Amazon FSx. Right? So there are in the EDA chip fabrication phase, there are different phases where the characteristics of the workload vary significantly. The front-end design phases are highly concurrent, single-threaded, and small file workloads, right? And millions of files. The back-end design phase are more multi-threading, memory-intensive, longer runtimes, and large sequential file patterns. So this customer, they migrated their workloads they lifted and shifted their on-premises ZFS and NetApp infrastructure to a familiar platform using Amazon FSx for NetApp ONTAP and OpenZFS, and they were able to run their workflows faster in the cloud. And once they were in the cloud, then they migrated to Lustre to build that scale-out solution and scale-out performance for their back-end design phases. Here's an example of another customer who built net new applications in the cloud. Right? Johnson & Johnson built their data science platform using Amazon EKS and EFS. Okay? And they use this platform to analyze genomic sequencing data and COVID data to support their various therapeutic use cases. By building this application using cloud-native services like EKS and EFS, and leveraging the EFS one-zone storage classes and intelligent tiering, they were able to reduce the cost by as much as 37%. Okay? And also improve their reduce their time to analyze this data by 35%. Let's look at what are the different cost optimization choices that you have available across the file storage portfolio. Right? All the file storage offerings offer you the choice of either single AZ or multi-AZ deployments. Right? Customers typically use multi-AZ deployments for the production workloads, and for test and development environments where you don't really need that multi-AZ latency, we have the option to use either one zone with EFS or a single AZ file system deployment option with the FSx family of services and optimize those costs. Across majority of our file storage portfolio, we offer the choice of either SSD or HDD storage options. So if you don't need that low latency, high performance of an SSD file storage, you can choose from the HDD storage offerings to optimize for costs. You also have the choice of configuring your performance levels. You can select different throughput tiers. You can configure your IOPS independently of the file system size, right? And optimize for costs as well. You can enable storage efficiency features, right? Across all our file storage, FSx file storage portfolio, we have compression supported, right? But some of the key capabilities that help you optimize costs are things like intelligent tiering, right, which I'll dive into shortly, and also things like deduplication as well as compaction. You can also, instead of when you need to test your dev production environment, right, clone it to your development or test environments. Let's say you are doing some kind of patching in your production environment and you want to clone that data. Instead of having to duplicate that data and copy that entire data set, you can use capabilities like clones to create near instantaneous writable copy of the data without having to duplicate that data set and innovate faster. So these are some of the different capabilities that are available when using our file storage portfolio. Let's look at NetApp ONTAP intelligent tiering. Right? You can enable tiering policies at a per volume level, and you can choose between 4 different tiering policies. Right? So when you provision a FSx for NetApp ONTAP file system, you provision a fixed amount of SSD capacity, which you can scale dynamically based on your application needs. There is also a capacity pool tier that is configured, which is fully elastic in nature. And when you enable a tiering policy, which is either snapshot only, none, auto, or all, right? It will intelligently tier inactive data from your SSD storage to your capacity pool tier and optimize for costs. And this is an example of assuming 80% of your data is inactive or cold, and 20% of your data is active, you can get an effective price point of 3 cents per gigabyte month using this capability. Okay. And you have the choice how you want to tier the data, right? Using all tiering policies, you can tier all the data from your SSD tier into the capacity pool tier. If you enable auto, it will only tier inactive data sets after a default period, which is 31 days, which you can customize to your needs. If you set it to none, then none of the data gets tiered. Everything stays in the SSD pool. If you use the snapshot-only policy, it will only tier inactive blocks from your snapshot from your SSD tier into the capacity pool tier. So you have that choice of based on your application needs, whether your application needs all the data to be in the SSD tier or to be optimized for performance, or whether you want to tier that inactive data, whether it's snapshot only or entire data set or just inactive data set. You can choose to enable tiering using all these different policies. We also support intelligent tiering with EFS. Right? With EFS, you have EFS one zone, which is the storage class for a single availability zone, and EFS standard, which is a storage class for multiple availability zones. Right? And you can configure lifecycle management policies with EFS, which allows you to intelligently tier data from these one zone and standard classes into the EFS one zone IA or EFS standard IA infrequently accessed storage classes. Right? And again, assuming an 80-20 split of inactive to active data set, by enabling intelligent tiering with our EFS one zone file systems, you can get an effective cost of 0.043 cents per gigabyte month, or an effective cost of 8 cents per gigabyte month for multi-AZ or EFS standard file systems. Okay. That's all I had in terms of the file storage today. If you haven't explored our training and certification content, I strongly encourage to check out the skill builder. There are over 500 plus digital courses available there, and pretty much all the file services that we talked about today, you have a 200 level course available there. Once you have explored the skill builder, we recommend you to take one of our certifications and get yourself certified using one of our 11 certifications that are available. And thank you. This is my contact information if you need get in touch with me. Hope you have found this session helpful today. We looked at the different file storage offerings, talked about what customers are doing at different stages of their file storage journey and cloud journey, and how you can use the different capabilities that we have in our file system offerings today to optimize costs and leverage the right file system for your workloads. I'm happy to take any questions you have. Sure.
Thank you. Does any of this Lustre support multi-protocol? We have some workloads, Windows and Linux simultaneously accessing.
Yeah. So for multi-protocol access, where you need to access the same data set from Windows as well as Linux, right? Typical use cases we see is on Windows, you want to access the data from using SMB protocol, and on Linux, you want to access the data from NFS protocol. Then our recommendation is to use FSx for NetApp ONTAP, because that is the service that supports multi-protocol for those workloads. Right? If your applications can work with NFS version 3, then you can also use Amazon FSx for OpenCFS, because you can use Amazon FSx for OpenCFS from Linux clients using NFS version 3 and all 4 NFS version 4. But from Windows clients, you can mount it, using an NFS client, which supports, NFS version 3. So those are the two choices, available from a multi-protocol perspective. Any other questions? Sure.
S3, I guess, has the intelligent tiering too. Oh, S3 has the intelligent tiering too. So what's the difference between EFS intelligent tiering and the S3 intelligent tiering?
Sure. In terms of how tiering works, they're pretty similar, but they're completely different, services, right? With S3, you're working with object storage and S3 APIs. You need to integrate your applications to work with, native S3 APIs, and you can enable intelligent tiering to tier data between the different S3 storage classes, right? But all these file systems or file storage offerings like EFS and FSx, they are built on, they provide a file interface, right, using either NFS or SMB protocols. Okay? So we see a lot of applications that, customers are either re-architecting to use, their applications make their applications work with S3, or they cannot, re-architect that applications and need that, file interface. So in that case, where you need, a POSIX file system or need a file interface for your applications, you cannot use S3 directly. So you still need to use, one of the file systems. And then when you configure a tiering policy, it will, monitor the access patterns and any inactive data based on, the lifecycle policy that you configure. With EFS, you can configure lifecycle management policies of, from 7 days all the way up to 90 days. And depending on, how you have set your lifecycle management policy, anything that is inactive after that many number of days will be intelligently tiered down to the infrequently accessed storage classes.
Okay, thanks.
Any other questions? Yeah. If there are no other questions, then please, complete the session survey. It'll help me, get the feedback on how I did today, and help me, improve for my future, presentations. Thank you.